Hello, this section is networking, understand pod networking concepts. This also covers a little bit about troubleshooting also, especially around logs. So we actually start off the video with a sidebar on the logging, and previously we were looking at events at the pod level, but the containers themselves have logs, and those logs are essentially as your process that it's your primary process running in your container. It writes to standard out and standard error, and both of those are stored as container logs in the cluster. Now, real quick, so let's just look and see what these logs look like. So I'm going to run a container, and let's look first at the container, the pod, and see what's in the pod. So the first one I'm going to look at is just debug. It's a simple little example, and it's a pod, right? Labels are normal, right? Now one thing I did here is it's running Ubuntu, and I just echo hello world out. And in here I set a restart policy of never. So we've been using the default, which was always so far. So this will basically just run and exit. So, and then the question is, how do we see what happened to the log? So let me run it real quick. So let's run it. So this is helm install dev debug. This installs it, and if I do control get pod, you'll notice it's completed. And if you get the detail on it, I'll describe. Okay, so you can see it's run, it's actually, but there's nothing in here that tells you that that word hello world is nowhere in here, so you can't really see it here. But there's another command you could do, is control logs, and then you give a container name, or a pod name. So you do kube control logs example dev, and there's your hello world, right? So you notice here I gave a pod name, not a container. So if you have multiple containers in there, you go container, like in this case it would be Ubuntu, right? And then, so that that gives you that. Now there's one other flag here you can give on this one, on the log. I don't know what log went, but kube control logs, right? So another command, another option you can give is, where's that logs at? Hang on. Whatever. Logs, example, dev. Okay, so another option you can give here is previous. So what this is, I'm not going to demo this, but if you have a container that happens to crash, right, and you want to look at the log, if you just do logs, it'll look at the current container, which may be fine. But you can do -- previous, and it'll tell you the last container that ran. You can get the logs from it. Okay, so that's another option. Now, one thing here is that the logs that you have here are pretty much like fairly ephemeral. It's just kept long enough for you to do some basic troubleshooting. If you need to keep logs longer, let's say after a pod, gets rescheduled or all sorts of things. If long story short, if you want something that's longer lived, you're going to have to install some add-ons that allow for those logs to be stored outside of Kubernetes. And so, for example, Amazon has a feature, which I'm not going to install it, but there's instructions on setting up container insights on Amazon EKS and Kubernetes. And basically, this allows you to take the logs that are running on all your containers and store them outside of into CloudWatch. So that's generally the idea. And behind the scenes, most of the implementations I see use this add-on called FluentD, which is a daemon set, which basically collects those logs and ships them somewhere. Okay, so that's just an interesting observation. So, okay, so we're done with logs for the moment, right? And now I want to switch over to pod networking. So the first thing you'll notice is that let me clean out the old example. So kube control, no, helm, uninstall, dev. Okay, get rid of that. Okay, so first thing you'll notice is that when you run your pods, they each get a unique IP address. So at the pod level, each pod has a unique IP address. And as such, so that's one thing to notice. Another thing to notice is, and we'll do it by example, if you have multiple containers within a single pod, right? The way they can communicate is almost like they're on the same host. They can use local host. And if they can do TCP IP across local host. And that's how you do intra-pod, inside the pod, one way of doing communication inside the pod. So let's just do it by example. I'm going to run another Helm chart. This one here is networking. So let's look at the networking example and see what it looks like. It looks like, okay, so this one is, because I'm trying to do two pods, you can see I got one pod with two containers. Here I've got Ubuntu just running there, kind of just looping, right? And then I've got an Apache web server that's serving up on port 80. And this is how the containers can expose their ports to the pod, right? They have to be unique within the scope of a pod, by the way. You can't have two containers in the same pod running on port 80. They have to be running on different ports. And another thing to keep in mind too, this ports option here is really more informational. So you got to make sure those containers are actually exposing the ports that, like, they're not overlapping, regardless of this configuration. This is more like telling the system, by the way, this container has this port. Even if you were not to specify this, that port would actually still be listening on at the pod level. So important to know that you need to pay attention what your containers are actually exporting, not just this configuration. Okay, let's go ahead and run this real quick and see a couple things about it. Networking. Okay, so first thing I'm going to do is I'll copy the command and we'll look at it real quick. Okay, so I'm going to run a command here on this window. So let's see what I'm doing. It says kube control logs, example dev, container HTTPD follow. So this is basically like doing a tail command where it's always watching for the output of that log. So as I do things interact with the HTTPD server, right, or the container, I'll see more logs here, right? And as you can see, basically it started up. My web server is basically running. Okay, I'm going to open up another window. Okay, and what am I going to do here? I'm going to log into my my other container. So let's see, oh, yeah, I'm actually going to log in. Actually, I'm going to log into, first of all, the HTTP container and poke around a little bit with it first. So hang on. So this is logging into the HTTP container. And you can see, this is my Apache web server. Okay, so what do I want to do here? Oh, okay. So what I want to illustrate is I can actually, I mean, it seems obvious, but I'm going to connect to the web page from itself. So the same container can talk to localhost and see the web page. So the way I could do that is I do apt. I don't have a browser on here, so I'm going to do quick apt. Apt get update. I'm just going to download curl real quick. This should only take about a minute. Apt get install curl. Okay, so if I now do curl localhost, right, I should be able to get the web page, right? And so it's working. So that's just illustrating that. You can validate that this is really running here, right? So if I go to cat hthost index, that is the file it's serving up. Okay. Now, this is going to be a quick sidebar here real quick. I'm going to look at the logs here and try to figure out how are the logs getting, where are they being stored, where are they going to, right? So the first thing I'll notice here is if I look at the logs file, which is normally where Apache would be storing log files, you notice that there's nothing here. And that's probably important because remember this writable container layer is really meant to be fairly ephemeral, and you really don't want to grow large. So this Apache server should not be writing a ton of logs into the file system, right? And we can actually see under the hood, ultimately those logs are going to standard out somehow. So the question is, how does Apache configure to make that work? And we'll just poke at this a little bit. Let me paste this in, and then we'll look to see what. So there's a configuration for for Apache web server, and the custom log entry is where it's pointing the logs to. And if I look at the output here, it's got this interesting syntax. This is a custom log is writing to the file system at proc self fd, which I believe is like probably file descriptor, and then 1. And if you were to look at this a little bit, Google around, this is essentially a way of writing to standard. So this is a process. The web server Apache is a web server process, and it's writing to its. This self is pointing to its own process ID, which is 1, coincidentally, and then it's writing to the field descriptor 1, which is standard out. So every time that Apache is logging, it's actually writing to the standard out of its process, which is actually being captured by Kubernetes. And we can illustrate this actually. One way just to sort of hijack the system here is if I just do echo hello, and I write to /proc 1, because in this case the process always runs as process 1, ID 1. And if this works right, if I was to look at my logs, I should see the word hello. So that hello's there because I just wrote to that file, which actually redirects to standard out. Okay, so that's just a quick sidebar into logs. And that one other thing too is, and we'll see this later too, but in this case I could actually send signals, right? I mean, if I'm on the box, I can send signals to that process. So I can, for example, do kill. This basically restarts the web server, right? And this is just a troubleshooting technique. I can basically send up a reset or like a restart process to the web server, and which is running on PID 1. And you'll notice if I look at the logs, after my hello, you can now see I basically restarted the web service here. Okay, so just another troubleshooting technique where you can send signals to your processes from the same container. Okay, so now we get a little more interesting here. Let's get off of this container here. And I'm going to log into the second container, which is really what I wanted to look at here, was, right, let's look at the other second container in the same pod, right, which is really the point we were trying to get after here. So I'm logging into the Ubuntu container, and I need to also, unfortunately, do apt-get update, and then apt-get install curl, and yes. And just like when I did it from the Apache container, I can also do curl localhost, and there it is, right? Now this is definitely different. This is a different box altogether, and so I'm able to communicate to the other container from localhost, even though this is not the same. Like if I look at ps-all-ux, you can see I'm running on a different container, and the only thing really running on this container is that tail command. There's no web services. There's no Apache running on this main box. So, but localhost nevertheless still points to sort of the pod level networking. Okay, so the next thing we want to do is talk about cluster networking. In particular, what we're going to do is we're going to look at how different pods can communicate amongst themselves. In addition to, so far we were looking at inside the one pod two containers. Now we're going to talk about two different containers in two different pods. So what I'm going to do here is, let me make sure I get the right window here. I want to leave my logs running for now. This one. Yeah, like too many windows here. Make this one bigger. Maybe make this one. Make it white so I don't keep on getting confused. Okay, so what I'm going to do is I'm going to run another pod. So I have another one called tester, which is just, you can look at it yourself. It's just Ubuntu, right? So let me run another pod. Okay. Where am I at here? Helm? Oh, I'm not in every folder here. Really? Okay, let's try that again. So I'm installing another Ubuntu instance in a different pod, and we're going to explore about how I can maybe access that same web page, but from a different pod is what we're trying to get after here. So if I do kube control get pods, you'll see I have now two pods. My example dev is the one I started off earlier. Example another is the one I'm just added right now. Okay, so what we're going to do is, we're going to log into it, and then we're going to try to, so let's do one more thing here. Let's look at kube control describe pod example dev. And what I'm getting after here, there's going to be an IP address here. So you'll notice that there's an IP address, 192.168. Let me copy this. So this is the pod's IP address, right? So what I'm going to do now is log into the other pod. So no, I'm going to have to just remember how to do this off the top of my head. Okay, so I'm going to do kube control exec. And I'm going to exec into another dev, interactive terminal. Let's see, did I do this right? No, what was it called? Oh, losing my mind. Okay, so now I'm on that one. And so what I want to do now is I want to do apt get update. A little tedious here. Then I'm install curl. And then I'm going to do curl. Now I'm going to use, so localhost should not do anything, right? Am I in the wrong box? I'm on the wrong box. Dang it. Okay. Really? Okay. I logged in the wrong box. Okay, so let's try this in. Apt. Kube control get pods. Get too many things going at once here. So it's not, I don't want to exec on the example, I want to example other. Dang it. Another. Okay, now I'm on the right box. Now there's no curl here, right? So no, so I have to do apt get update. Apt get install curl. Okay. Okay, so I thought that was awfully quick. So now again, I'm on a different pod, and so which means is if I do curl localhost, it should fail, right? Because that pod doesn't have the web container in it, right? But if I do curl on the IP address of the other pod, I get that, right? So that's so that pod IP address is how I have two different pods with different containers in each, and then that one container with Ubuntu in it can talk to the other container other pod and the container in it, and get the web page off of it, right? So the question now is, thinking about this, be like, well, how in the world does this all working underneath the hood, right? I mean, we got really a node underneath this whole thing. How is different pods and different containers talking to each other somehow, even though they're like potentially on different nodes, right? So what we're going to do is I'm going to log into the node itself, and we're going to do some poking around, and then I'm going to walk you through this diagram here to illustrate kind of what's going on, right? So the first thing I'm going to do is log into the node itself and see what happens if I curl that same IP address, right? So, so what I'm going to do here is let me get off of this box here, and I think I already had this earlier. So I can go to AWS, look at the, there's a number of ways I can get the IP address of my node. I think I already did this earlier. So I already had logged into it, so I'm going to log into my node. So I'm using the -a secure shell -a EC2 user, EC2-user, right? So I'm logged into, what? Okay, one more time. Bang 1957. Okay, there we go. So now I'm on my, this is actually my Bastion host, right? I'm sorry, that's my Bastion host. Now I can log into my node. Now I'm on my node, and I'm going to just go sudo interactive. Okay, so I'm on my node, right? And then I think I've already installed curl here. I actually did this earlier. So in this case, I could have done apt-get update, apt-get install curl. So now I have curl. And if I do curl, let's see if I can actually, and so from my node, I can also use that same IP address and get to that web page that's running on that pod. Okay. Now this is a little unusual troubleshooting, but is a way to troubleshoot this. So I'm going to see if I can use some commands at the node level right now to see kind of how this networking, I mean, how does this IP address even where is it at and how does it work? And what I'm going to do is I'm going to use this diagram here. I'm going to walk through how, walk through how communication will work across between pods, essentially, between containers and pods. Okay, so the first example I'm going to give is where I have a single node, right? So I have a node on the left, right? It's in a subnet, right? From, in this case, AWS, right? The node itself has an IP address, and the pods have IP addresses, right? So I have two pods, and I'm imagining this bottom pod B is trying to communicate with the other container in that pod, right? And the way this works is, I'm going to show you a couple commands that'll give you a clue. The first thing to notice is if I go to, now I'm using AWS, so I'm going to log in AWS real quick, and I'm going to show you something to pay attention to. Actually, maybe I can find this easier if I did it this way. If I go to EC2, I'm going to look at the node itself, and any instances, I'm going to look at the node, which is this top one. Okay, so first thing you'll notice, it's in a subnet. Let's see, where's this subnet here? Okay, it's in a subnet. Let's look at what subnet this is in. This subnet is in, the IP subnet is 192.168.192.0.18. And if you look at that IP address that we had on the pod, which was 192.168, you will notice that the IP addresses of the pods are in the same space as the subnet that the node's in. And the reason why that is that, if you recall, we actually used it, when we use EKS, there's an add-on added to our cluster that allows for the pod networking is basically tied to the VPC. So basically my pod IP addresses are actually coming out of my subnet. And matter of fact, if you look at the node itself, you'll see that there's all of a sudden now all these secondary IP addresses, and one of which is, what was the ending of our IP address here? It was hang on, let me pause this. Okay, I'm back. Real quick, so the IP address of the pod was 248, and if you look through this list, it's right here. So you'll notice that all of a sudden now my node actually has that same IP address set up as a secondary IP address on the node itself. Okay, so that's another. So the two interesting observation was, one is the IP addresses are in the same subnet the nodes are in, and two, they're actually being assigned against the secondary IP addresses on the nodes. And this is one of the reasons why, by the way, early on we made sure that we had very large subnets that our nodes were in, because every time we use another pod, we're eating up IP addresses out of that space. And so every pod, and then just so you know, the reason why there's all these different IP addresses already assigned, there were, behind the scenes, there were some system level container pods basically being run, right? And those all ate up IP addresses. Secondarily, the add-on automatically pre-allocates extra IP addresses so that it can quickly spin up pods. So that's essentially why there's so many IP addresses already associated with my node. Okay, now let's go back to this diagram. So what we're looking at here is, let me see if I can orient you. Imagine it, forget there's two nodes. Let's focus on the fact there's only one node right now. So the node itself has an IP address, and I'll just call it some 192.190.68, and then X is the number. So pay attention to this X on the last, right? And then I have two pods on it with two different IP addresses, A and B, right? So the first thing will happen is at the node level, it will also set up these secondary addresses A and B here also, right? So this is what we were just seeing a minute ago. So every pod IP address gets exposed as a secondary address on the node. Okay. Now the way this communication works is we can do a command. See if I can get this right. So I'm on the node, right? And if I do a command called route, right? And what this basically does, it tells you how the node is routing traffic based on IP addresses. So there's two in here I want to pay attention to. One is 192.168.192.0, right? This is basically saying, wait, is this the one I want? Yeah. Okay, hang on. Let me pause the video for a second and make sure I'm not confused. And back. I just saw this 192 twice and it freaked me out. So the IP address for the subnet is 192.168.192.0. That's the subnet itself, right? And then this subnet mask that's on it here is the same thing as that /18. If you were to figure out how to use a subnet calculator, this is actually the same thing as a /18. So basically now this basically says, hey, if you have any IP address, right, that is in the subnet space, send it to the Ethernet output, which basically dumps it on the subnet, and that's how different nodes can communicate amongst themselves, right? That's just a normal route, basically, to the subnet, okay? Now, there's a couple interesting ones here in particular, though, is, if I remember right, let's see if I remember, my IP address of my pod was 248. So right here, it's this entry right here. So one of the things that the AWS add-on does is it helps manage this process of allocating IP addresses. And you notice that it's updating the routing table on my host, on my node, says, oh, if you need to go 192.168 to this IP address, right, says dump it to this ENI address right here, which now this is a different interface, right? And so what happens is if you do if config, I think it is, right? This tells you all the interfaces that this host has. And what happens is for every pod you have, you will get another one of these interfaces like this. So, um, so that particular interface is tied directly to the pod. So this basically says if you get to this, if somehow this box sees that IP address to 248, says send it to this interface, which is then tied to the pod in question, and the traffic gets to the pod, and then eventually the pod gets the port on the pod, and the pod, your container gets it. Okay, so long story short, see if I can flow through this, two different flows in this diagram. For example, if I'm on two containers on the same pod, let's say this pod B with the address of B is trying to get to traffic to pod A. What it does is it dumps it out to the node. The node looks up at that routing table and says, oh, I need to get to the IP address, whatever, dot A, right? Again, these are just, the A's and B's are just, I mean, I didn't want to put actual numbers on it, so this represents some number, right? And so it needs to get there. It looks at the routing table, sees that A is tied to some interface, ENI XXXXX, and then it gets directly to the other pod. So that's how the traffic gets actually into the node's routing table and then gets to the pod that way. Okay. Now, what happens if I have to do intra-pod communication? So I'm on, this is kind of the example we gave earlier, and I'm going to do the example where, well, let me phrase it, pods on different nodes is what we're doing now. And so I have a pod now that's sitting on a separate node, which I don't have right now in my actual example because I'm only running one node. But imagine I have a separate pod, a separate node, and the pod is running over there, right? So what it does is if it says, okay, I need to go to the address, for example, A, right? It says, well, I don't know what to do. So it dumps it out to the node. The node looks at this routing tables, and there's no immediate route to an interface like for just that IP address, right? Because that pod is not on this node. So it uses the default route, says, oh, okay, that whole subnet dumps out on Ethernet 0, which then basically goes out on the subnet. And because this guy is listening for that IP address, right? He's listening for 192.168A. It says, oh, I have it. So this node picks up that traffic, right, on Ethernet 0. Then it drops it into the routing tables here, and the routing table here says, oh, 192.168A needs to go to this ENIX interface. So internally within the node, it moves it to that interface, which gets to that pod, which then gets the traffic to the container that's listening. Okay? So the key thing here is the nodes actually use their internal routing tables to then move traffic between, basically from an IP address to a pod on like a virtual interface or one of these ENI interfaces. Okay, I'm not sure if it all makes sense, but that's basically an example of how this flow goes. And the commands I used to sort of debug this, again, I was using route, right, on the node and looking at the routing tables. And then I was using ifconfig to see the interfaces, and I can actually see a little bit more information about them. Okay, so there was a little bit about, see if there's one. Okay, so that's it for that topic. Now we're going to finish up this last, so I'm going to shut all this down. So let me get out of all this. Exit, exit, exit. Okay, I want to kill this log. Okay, I'm going to get out of this all the window. Okay, so now I'm going to go helm ls, helm uninstall dev, and then helm uninstall another. Okay, so the last thing I want to talk about. So far, this is kind of a sort of a sidebar. In the last examples, a couple while ago, we were talking about two different containers in the same pod, and they were communicating amongst themselves using TCP/IP on ports, right, on the local host, through localhost, right. Now there's another way that they can directly communicate, and that's called I think it's called interprocess communication. It's a Unix thing. And basically, you can send messages you can share memory, you can send messages across it. It's probably outside the scope, the full scope of it's outside the scope of this video, but I'm going to do a very simple example of that. And where I send signals, which is like, basically I'm going to restart from one container. I'm going to tell the web server in a second container to restart itself. Kind of like what we did earlier, but when we did it last time, we were on the same container. Okay, so the way we're going to do this is we're going to look at the code here. So there's another chart here. So this one is called IPC, right? And this chart looks like very similar. There's two containers, right? Now, there's a couple things different. One's Ubuntu, one's the web server, right? But first thing you'll notice is that there's a share process namespace true. So this needs to be turned on before you can do this, right? And this allows that inter-process communication between two different containers in the same pod. And then, and again, there's an article about this that Kubernetes folks had put together, so I just basically followed theirs. But you also from the Ubuntu side, I need to be able to send signals, and there's some security controls around how this works. So the example they gave basically told me I needed to enable Ubuntu to send signals by enabling this capability of sysptrace. So I don't fully understand it, except for that's the example they gave, right? So basically, this is what's allowed me to do inter-process communication, so I can send signals between my containers without using the regular local host web stuff or TCP/IP stuff. Okay, so let me run this real quick, and then we'll see how this works. So if I do helm install IPC, helm install dev IPC. Let's see what I need to do. So the first thing I'm going to do is I'm going to run logs, on one of them. So let me do that first. I guess I'm going to have to open another terminal again. So what I'm going to first do is I'm going to run the logs on the web server, right? So I can see what's happening with the web server. Now I need to go into log into the Ubuntu container, right, which is the second container in this pod. Okay, so first I'm going to do here is I'm going to do a ps minus aux, which is basically showing all the processes. Now, one thing that you'll notice is slightly different is when I ran ps, when I wasn't doing this shared inter-process communication stuff, I didn't see near as much as this. I only saw PID1 was the process of whatever the container was running, right? And then I think that's all I really saw, right? But here you'll notice you actually see a lot more. Matter of fact, you actually can see, so here's right here, PID7 is my own process, but I'm actually seeing the other processes in the other containers, right? And remember that there was that whole hidden pause container? That's what this one is. So one is actually the pause container, the hidden container. But here's my web services right here. So this is basically my web services. And looks like the main one, the parent process here is 12, right? So it's running on PID 12. So if I do kill minus hup, which is a signal to restart itself, 12, right? If I do this, what I should have seen in my log, see how, well, it's hard to see here a little bit, but previously this was all here. And then when I did that, I actually got this extra one. I guess I could watch it here. See if I can, I don't know. If I try to do that again, but watch the screen, there, it just flipped over there. So it just restarted itself. So this is a way of allowing one container to directly interact with the processes in another container using IPC. Okay, and I think that is the entirety of this video. Thank you.